Day 306 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 140, word break 2. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out the link in the description so you can get you some. Now let's see what the question says. Given the it says given the string S and a dictionary of strings word dict, add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Note that the same word in the dictionary may be reused multiple times in this segmentation. All right, y'all. So now that we've read the question, let's go ahead and take a look at these examples so we can make sure that we're doing the problem correctly. So in example 1, we have the input S equals this string, cats and dog, all one word or all one string. Well, yeah, all one word. And word dict equals an array of strings, cat, cats, and sand and dog. The output is an array of strings, cats and dogs, cats, sand, dogs. Now, let's figure out how they got this output from the input that they gave us, right? So as you can see, each word in, each string in the output consists of words that we can create from this input S, right? So if we put a space in between cats and, we get cats and right here, and then we put a space in between and dog, we get and dog. That's how we get cats and dogs. Now, it's important to understand that cats, all three of these words can be found in the input word dict, right? We have cats and right here, and then we have dog over here. But that's not it. We're not done yet because we have to return all of the possible sentences that we can create in any order, right? Like it says right here. So another way another sentence we can create is we could just take cat, because cat is right here in the word dict, right? So it has cats and cats. So we can have cat without the S right here. Then we could put sand. You see, sand is also in the word dictionary, right? So we could put sand, and then we could put dog right here. Boom. Cat, sand, dog, or cats and dog, right? Those are the two sentences we can form by putting spaces at different points in this input string S. So that's what they want us to do. They want us to take the input string S, and then they give us the word dict, and they want to see how many sentences can we form from this string S that include words from the word dict, right? So let's go ahead and take a look at example 2 just to make sure that we understand the problem correctly, y'all, because I know that might be a little difficult to understand for some. So let's go ahead and take a look at example 2. So in example 2, we have the input S equals a string pineapple, pineapple, or pineapple, pineapple. I don't know what this word was. It's a string with different words in it, right? Then we have words dict, and that has a dict, or that is an array of strings. We have apple, pen, pine, pineapple, right? The output is also an array of strings: pineapple, pen, apple, pineapple, pen, apple, and pine, apple, pen, apple. So as you can see, we can create each one of these words from this string. And it's also important to realize that each one of these words can be found in word dict, right? So we have pine right here, boom. We have apple right here, boom. We have pen right here, boom. And then we have apple right here again. Because once it says, note that the same word in the dictionary may be reused multiple times in this segmentation. So in example 2, in this output, we have apple twice. So let's see how we can let's see how we got this apple. Or excuse me, no, we don't have apple. We don't have apple twice. These are different strings. Oh yeah, we do have apple twice. We have apple here, and we have apple here. So yeah, let's see how they got this, right? So first we've got pine. Pine is right here. Boom, we put a space in between this E and A. We get pine, then we get apple right here. Boom, we put the space between this E and this P. Then we get pen right here. Boom, we put a space between this N and this A, then we have apple right here. Boom. So that's how we got this string right here. Then this string, and once again, all of these words will be found or can be found in word dict. Boom. So then we did the same thing because we need all possible sentences. So the next sentence will be pineapple, pen, apple, which will be right here. We have pineapple. Boom. Put a space in between the E and the pen, E and the P. Then we have pen. Boom. Put a space between the N and the A. Then we have apple. Boom. And that's how we get pineapple, pen, apple. Then last but not least, we have pine, apple, pen, apple, right? So we could get pine right here. Boom. Put a space between the E and the A. Then we have apple, pen. That's one word that can be found right here in the dictionary. Boom. So we put apple, pen. We put a space in between the N and the A for apple. And then we get apple right here. Boom. Apple right here. So that's how we got this output from this input. Boom. So now let's look at example 3. Example 3 is a little bit easier, but it's sort of like a trick question because this time the output, we could not form any sentences. So in example 3, we have S equals this string, cats and dog. Again, word dict equals an array of strings, cats, dogs, sand, and cat. Now, we can get cats, boom. Cats is right here. Then we could get and, boom. And is right here. But as you can see, after we do and, the only thing left is the O and G, and there is no way that we could form a sentence with the word OG because OG is not in the dictionary. So we can't use that one. Boom. OG is not down here, so we can't use that one. We could try it like this. We could do cat right here. We have cat over here. Boom. Then we do sand. We have sand right here. Boom. But once again, after sand, we'd still be left with that OG. And since OG is not included in the word dict, then we cannot include that sentence either. And thus the output is going to be a blank array because it's impossible to use every word in this string, or every letter in this string and create a full sentence that includes all words from this word dict array. So I hope that made sense to y'all. If not, go ahead and look over it again, go through it again, watch that part again until it makes sense for y'all. But if it does make sense, now let's get into the fun part, the actual solution, y'all. As y'all already know, the solution is not that difficult, so let's get into it. Now, the first thing we need to do is we need to create a dictionary cache that will cache previously computed results, and that will help us to avoid redundant computations. So to do that, we're going to come outside of the func, but in the class, and we're going to declare a variable. Excuse me, y'all. We're going to declare a variable, and we're going to call that cache. We're going to say colon, open up the square brackets. We're going to say string, colon. Then that's going to be an array. After the colon is going to be an array of strings. So we're going to say square bracket string. Then we're going to come outside of those square brackets and we're going to initialize it with a blank dictionary like this. So what this is, it's a dictionary with a key string, and the value is going to be an array of strings. Boom. Now let's get into the function that we're actually going to write. Now, first thing we need to do is we need to check if the result for the string S is already computed and stored in cache. So to do that, we're just going to say if let ans equals cache, then, cache square bracket S, then what we are going to do, we're going to open up the brackets and we're just going to return ans. Boom. Now we need to create a variable that's going to store all the possible sentences that can be formed. Right? So to do that, we know that our output is going to be an array of strings. So we need to create that array of strings to store our output. So we're going to declare a variable called ans, and we are going to we're going to say colon. Then we're going to open up the square bracket string. So we're going to cast that as an array of strings, and we're going to start it off with a blank array. Boom. Now we need to iterate through each word in the word dictionary. So we could just say for word in word dict. Then we open up the brackets, and we need to check if the string S starts with the current word. So to do that, we'll say if S dot prefix, or excuse me, that dot has prefix. If S dot has prefix, open up the parentheses word. This is going to check S to see if it has the prefix that is equal to word, which means we found the word that's in the dict. So then we're going to open up the brackets, and we are going to say, first we need to see if S is exactly the same as word, then we can add it as a valid sentence. So if S.count equals word.count, then we could just append word. So we're going to say if S.count equals equal sign word.count, boom. Then we could just open up the brackets, and we can say ands.append, open up the parentheses, word, like that. Else, we're going to have to do some more work, and we need to extract the remaining substring after removing the word. So in order to do that, we could just say let sub str equal s dot substring, open up the parentheses, from word dot end index, just like that. Now we're going to recursively find all possible word combinations for the remaining substring. So in order to do that, come right here, we're going to declare a variable called sub words. We'll set that equal to word break, which is where the recursion comes from. That's the name of the function. Sub words equals word break, open up the parentheses, sub str, comma, word dict. Boom, just like that. Now we need to combine the current word with each valid sub sentence. So we could come underneath this variable, and we could say for sub str and sub words. Then we could open up the brackets, and we could say ands.append, open up the parentheses, word, plus plus quotation marks, put the space in there so we know where to add the space at. Then we'll come outside of that, and we'll say plus add sub str, sub str, like that. Boom. Now we need to store all the computed results in the cache to optimize the future calls. So we could just come down here, boom, and we could just say cache square bracket S equals ands, come underneath that, and we can return all possible sentences by saying return ands, just like that, y'all. So let's give it a run, see what happens when we run it. Okay, oh, we got a period. I was trying to get it first try, but it's a typo, so let's keep going. Let's try it again, see what happens. Okay, cannot find sub words. Sorry, y'all, all these typos. This should be capital W. Let's run it again. Let's see, and it's accepted, y'all. Look at that. Let's go ahead and submit it. Make sure it stays accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users with Swift. Not too shabby, y'all. Not too shabby at all. So before we leave, make sure y'all get one more look at the code. This is the top half right here for y'all. Read it, learn it, love it. Go ahead and look at the bottom half. This is the bottom half. Read it, learn it, love it, understand it, internalize it. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.